This video is about absolute value functions and transformations. So let's review that a parent function is the most basic version of any function, and then the transformations of it are all the different changes you could make to the parent function. So some of the transformations you could make to this V-shaped function would be to slide it to the left or slide it to the right. When you slide something to the left or right, it's called a horizontal translation. You could slide the V function up and down, so you could slide the V up, or you could do some combination where you're sliding it to the right and you're sliding it down. Any movement up or down is called a vertical translation. You could reflect the V over the x-axis. You could also reflect it over the y-axis, but it would look exactly the same. Reflect it over the x-axis is called reflection. You can stretch your V, make it a tall, narrow V. That's called a stretch. Or, and I'll show this one reflected so you can see it a little easier, or you can compress the V and make it a wider V. So if you're making your V rise more slowly or fall more slowly, it's called a compression. So these are the transformations we'll be doing. Let's see where the V shape comes from, the original parent function. The absolute value function has a V-shaped parent. Let's see why. We're going to create a table for this one. When you create a table for a function, you just choose some x values to plug in so that you can get a representation of what's happening on the left and what's happening on the right. So when you plug in -2 to the absolute value function, you're plugging in the -2 here, and it's the absolute value of -2. And the absolute value of a -2 is +2. So that means y is going to be 2 when x is -2. Continue plugging in values. The absolute value of 0 is 0, and the absolute value of a positive is also positive. So you see what's happening with these y values here. They're all positive. They go down to 0, and they turn around and start rising again. So when you plot these points, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2, you see that they create the V-shaped parent function. So this is the parent function for absolute value. It's the most basic one, absolute value of x, with no transformations at all. When you start putting transformations into the equation, so adding things or subtracting things or multiplying by other numbers, that's when you get a different version of the equation on the graph. So putting numbers into the parent function create a different version of the graph or a different transformation. For just this one, we're going to continue making a table. After this, we will learn a shortcut so we don't have to use a table every time. But using the table here illustrates something interesting. So let's use the same 5 x values, which aren't necessarily the best x values for this one, but you'll see. When you plug in a -2, this time you have to do a little math. So plugging in the -2 and then subtracting 1 gives you -3. The absolute value of -3 is +3, and then add 2 and it's 5. Plug in -1. -1 minus 1 is -2. The absolute value of that is 2, plus 2 is 4. Plug in 0 and it's 3. Plug in 1 and it's 2. And then when you plug in 2, it turns around again and starts going up to 3. So this time the graph is decreasing until it reaches 2 and then it starts increasing again. So if we plot these points, we have -2, 5, -1, 4, 0, 3, 1, 2, and then 2, 3 is where it turns around again. So if you can continue this V, you imagine that's going to keep rising here. So the V shape looks like this. So as you can see, it's the same parent, it's the same as the parent function with 2 big changes. The vertex, the center of the V, let's label that now because this word is going to come up again and again. It's pretty important. Vertex. The vertex of the V has shifted to the right 1 and up 2 from where it used to be. So it used to be located at 0, 0. Now we've got some numbers in the equation that tell us where the new vertex is going to be located. So the vertex here is located over to the right 1, and it's located up 2. And that's indicated by the numbers in the equation. So let's go through different locations of numbers in the equation and figure out how they affect the graph. A horizontal translation, which means a slide to the left or right, is determined by the number located here in the equation. Right here, the one that is inside of the absolute value being added or subtracted from x. And you notice this general form of the absolute value function has a minus inside, and that's to remind you that the number inside goes the opposite direction of what you would think based on what you're looking at. So if it says h is a negative value, like x minus h, then the graph is going to be shifted to the right. If h is positive, the graph is shifted to the left. This is actually a little erroneously written, but the idea is if you see an equation like this, y equals the absolute value of x minus 1 plus 7. Okay, it's the minus 1 that is affecting a horizontal translation. And because it says x minus 1, that means your vertex is going to be shifted to the right 1 unit. Even though it looks like, because it says minus 1, you think, oh, I'm shifting it to the left because negative x is to the left. You do the opposite of what it says. That's why the formula has a minus h in it. If it's positive, then the graph is shifted to the left. So if your function was this, x plus 1, then you would shift this to the left 1 unit. But really, I shouldn't have said if h is negative and if h is positive, because of the minus sign that's in the formula. If h was negative, it would actually be x plus a number. But you get the idea here. If it's subtraction inside of the absolute value, then it's shifting it to the right. And if it's addition inside of the absolute value, then you're shifting it to the left. A vertical translation is determined by the number located here at the end. And this number does not have a minus sign in front of it. That just indicates that if it says plus, you go up, and if it says minus, you go down, exactly as you would think. So if k is negative, the graph is shifted down. If k is positive, the graph is shifted up by however many units that says. So you can imagine that you have the function y equals, we use the same one we just wrote, x plus 1 inside plus 7 outside. The new vertex of this graph is located at the opposite of h, comma, not the opposite of k, right? So if it says x plus 1, that means the vertex will be located at an x value of negative 1, so we do the opposite of h, and a y value of 7. So this is hk. So if I ever say, oh, start graphic by plotting hk, I'm saying put the vertex on the graph. And that's the new center of the v, right? Because the vertex used to be 0, 0. The h and the k tell you how far to move it. So the new center of the v will be located at hk. And then all the other transformations are determined by this last variable. Vertical stretch, vertical compression, or reflection. And I've just been referring to this as a stretch or a compression, which is fine. It's vertical in the sense that you're stretching it up, you're stretching your y values, or you're compressing your y values. That's why it's called vertical. But you can just continue calling that a stretch or a compression when you write this in your notes. It's determined by the number located in front of the absolute value, the coefficient, the one being multiplied by. So this a value here. It's almost like the slope. So same location as the slope, right? It's in front of x. And the slope really only applies to a line. So it's called a instead of m, which is what we usually would call slope, right? And if a is negative, then the graph is going to be reflected. So if you have a y equals negative 2 times the absolute value of some other stuff, it's the negative that flips this thing upside down. If the absolute value of a is greater than 1, then the graph has a vertical stretch. So it's going to be taller and skinnier the greater the absolute value of a is. And we say absolute value because we want you to ignore the negative. The negative is just what flips it upside down. The actual value of a, if it is a number greater than 1, the higher it is, the more stretched out it is. If the value of a without the negative sign is less than 1, that would be something like y equals negative 1/3 and some other stuff after it. So if the a value is 1/3, remember ignoring the negative sign, that's when you get the compression, the wider v that kind of moves more slowly in the downward direction. So you can see the way that a affects the shape of the graph. So now we can use those h, k, and a values to graph it without creating a table. So for your first step, you want to plot the vertex at hk. So the vertex of this function that we're looking at up here is going to be the opposite of h, and then not the opposite of k, so negative 1, 4. So I'm going to plot that point first. That is the center of the v for this function. From here, the easiest way to get the graph is to use A like a slope. Okay, so use A like a slope, only on one side the slope is going to be positive 1/3, on the other side the slope is going to be negative 1/3, because you need to get a V that comes out of this thing going both directions. So basically, I treat the top of the fraction as the rise, and the bottom of the fraction as the run. So the 1 is the rise and the 3 is the run. Because it's negative, I'm going to go down. So I'm going to go from my vertex, I'm going to go down 1, and then I'm going to run 3 units, 1, 2, 3 to the left, and 1, 2, 3 to the right. This is how I'm going to create a V shape. So on one side your slope's negative, on the other side your slope's positive. And then I do the same thing again. Down 1 over 3, down 1 over 3, and I get this wide, compressed, reflected V. Let's do one more. So I want to start by plotting the vertex, which is located at the opposite of H, comma, not the opposite of K. So 1, negative 4. That's the center of the V, called the vertex. And then I'm going to use the A value, so positive 2 over 1. I'm going to turn it into a fraction if it's not a fraction. Use that A value as a slope to go up 2 over 1 in both directions. And then again, up 2 over 1 in both directions to create that V shape. So on one side the slope is positive 2, on the other side the slope is negative 2. And that is all.